What is eccentricity in orbital insertion? Imagine launching a satellite into space and watching it settle into its orbit. The shape of that orbit depends on many factors, and one of the most important is called eccentricity. Eccentricity is a number that tells us how much an orbit looks like a perfect circle or an elongated ellipse. It is a simple ratio that compares the distance between the two focus points of an elliptical orbit to the length of its longest diameter. If the eccentricity is 0, the orbit is a perfect circle, meaning the satellite stays at the same distance from the planet or star at all times. When the eccentricity is greater than 0 but less than 1, the orbit becomes oval-shaped or elliptical. This means the satellite gets closer to the planet at one point called periapsis and farther away at apoapsis. The higher the eccentricity, the more elongated the orbit appears. If the eccentricity reaches exactly 1, the orbit is parabolic, which is a boundary case between an orbit that stays bound and one that escapes into space. If the eccentricity exceeds 1, the orbit is hyperbolic, meaning the satellite is on a path that takes it away from the planet forever. In the context of orbital insertion, eccentricity is very important because it shapes how the satellite moves around its host body. After a spacecraft is launched and reaches its transfer orbit, mission planners use propulsion burns to adjust the velocity and trajectory so that the satellite ends up with the desired eccentricity. For example, a low eccentricity orbit, close to a circle, is often used for communication satellites because it provides stable coverage. On the other hand, some scientific missions need highly elliptical orbits to observe different parts of space or Earth at varying distances. Eccentricity also affects the satellite's speed at different points in its orbit. When the satellite is near periapsis, it moves faster, and when it is near apoapsis, it moves slower. This variation is directly related to the shape of the orbit. During orbital insertion, engineers carefully plan the burns to set the right eccentricity so the satellite can perform its mission efficiently. In summary, eccentricity in orbital insertion describes how oval or circular an orbit is right after the satellite is placed into space. It influences the satellite's speed, altitude, and coverage area, making it a key element in designing successful satellite missions.